topic of this video is to determine relative max and min values. This video will show you kind of the general idea and the way to estimate what those values are. Whenever I show you the calculator, I'll show you how to do that specifically so that you can find the exact values of the maximum and minimum. So first, just understand it's kind of connected to the last objective that we talked about, the increasing and decreasing. If you recall, we talked about how those increasing and decreasing change at the turning points. Well, that's really where our relative max and min occur. That is where a function has a turning point, where the function changes its increasing, decreasing, or constant behavior. So what do we mean by relative max? A function value f of b, so here we're talking about the y value, okay? Anytime we talk about relative max or min, we're talking about the output value. So the y value is a relative maximum of a function if there is an interval around the x value b for which f of b is the largest y value. So we think about, here's the value of b, here is f of b. So we're talking about somewhere around f of b, or around b, that output value f of b has to be the highest. So it's kind of a peak, if you will, of the graph. A function value f of b, again the y value, is a relative minimum of a function if there is an interval around the x value b for which f of b is the smallest y value. So this is saying, here's my value of b, here is f of b, but around b, f of b is the smallest y value there. So a minimum occurs where there is a valley. So it's kind of the high and low points. Hopefully that is pretty straightforward for you. So let's look at what the relative max and min would be for these examples that I have here. You may recognize this graph. It was one that we talked about where it was increasing and decreasing. And so notice that there is a peak and a valley. So that means that this function has a relative max and a relative min. The relative max occurs at the peak, and the relative min at the valley. And so to state what the relative max is, we want to state what is the y value at this particular high point. So that looked to be approximately 1. So we would say this function has a relative max at 1. Well, it occurs at that, negative 0.2 or whatever that x value happens to be. What about the relative min? The relative min is, again, a y value. It looks somewhere between negative 1 and negative 2, closer to the negative 2. So approximating that, we'll say it's negative 1.8. Okay? So we answer with the y value at the high and low points. Now I'm giving you an illustration where the graph is not given, and you're thinking, I don't even know how to graph something like this, x cubed minus 4x, but we're just going to go back to the old plotting points method. So really where you want to start with x cubed minus 4x, and some of you may recall how to graph a polynomial from college algebra, but start with the intercepts, that is the y-intercept, the x-intercept. The y-intercept is when we plug in 0, what do we get? Well, 0 cubed minus 4 times 0 is just going to be 0. The x-intercept is when we set that function equal to 0 and solve. So if we do that, we would take out an x, and that leaves x squared minus 4, and then that's the difference of two squares. So we have three intercepts at 0, negative 2, and 2. And then what you would want to do is just to approximate the way the graph looks by choosing values of x to plug in, and those values of x should be around your intercept. So for instance, if I wanted to choose like negative 1, that's between negative 2 and 0, if I plug in negative 1, I would get Negative 1 cubed is negative 1 minus 4 times negative 1. So what is that? Negative 1 plus 4, which would be 3. So at negative 1, our output is 3. And between the 0 and the 2, we can plug in 1. So there we would have 1 cubed minus 4 times 1. So 1 minus 4, which would be negative 3. And then to the right and left of the 2 and negative 2, to the right of 2, let's plug in 3. So 3 cubed would be 27 minus 4 times 3 is 12. So 27 minus 12 would be 15. So when we plug in 3, we have an output of 15. Which is going to be up off my graph, but somewhere up here. And then if we plug in negative 3, negative 3 cubed is negative 27. And we would get negative 27 plus 12, which is negative 15. So again, that's going to be kind of off my graph. But the key now, I'm going to draw the graph. Oops, let me take it out of here. This is hard to do on a graphing tablet, so I apologize. Should be going through these points and kind of up to this turning point and back down. And 3, 0, 0. You guys use your imagination. I'll draw that more precisely whenever I have a minute and not on this video, so please forgive me. But we see we have a high point and a low point. So that would correspond to our relative max and relative min. So it appears that our relative max is at this y value of, what, 3. And our relative min, again, this is just approximating for now, and I'll show you precisely in the calculator, our relative min would be at negative 3. Okay, so the key to this objective is just simply understanding what the max and min are. Those are the y values at those turning points where a function changes from increasing to decreasing or constant. Okay?